Yeah. So guys, good afternoon everyone. I hope everyone is doing good. Correct. So can you guys hear me? Please let me know through the chat box. If you guys hear me, please let me know through the chat box. Yeah. So guys, good afternoon everyone. Okay. So I think everyone can see my screen now. Correct. So guys, if you see my screen, please let me know through the chat box. Yeah, pretty, like, hello, who is this Tun? YouTube friends. If anyone is there, please let me know through the chat box. All my YouTube friends and yeah. So if my YouTube friends are there, then you how you are joining the class? Soon you are from which which school? Please mention in the chat box. So okay, guys, I know that many people are having issues with that. Okay, right. So now let me tell you. I don't want to take much time about what are the things we need to discuss and everything and all. I'm going bit in a simple way, fast way. I can say that the reason because in the examination point of view, and we are having 30 minutes of time, 30 minutes of time. So I don't want to waste much time here. So just I need to focus on the basic stuff which I really need to discuss in the examination. Okay. So how the chemical bond is formed, what are the requirements are there? I don't want to discuss here. Hello, Janvi Rajkot. How are you guys? I hope you all are doing good. Correct. Yes, I'm missing you people. In the last class, I couldn't have a chance to meet you all. But today, I think you people will respond in the chat box for sure. Okay. So now the basic idea of this class is to give the glimpse of chemical bonding. Yes, good afternoon. I think after having a post lunch, having online class, I know it how it will be, but I don't want to bore you much. I will give you the brief idea about the chapter, what you need to focus more, and how to do this. In your examination point of view, why we need to read the chemical bonding and all these definitions. I don't want to go, but what is important for your exam point of view, I'll discuss that today. Okay. Yes. So now we know that chemical bonding is simply nothing but it's a force of attraction between two atoms. Let's suppose this is atom A and atom A. And if you are making a bond between A and A, so there is some driving force is required to form a bond between A and A. This particular driving force is simply nothing but what? Chemical bond. So this driving force is simply nothing but called as chemical bond. So chemical bond is very simple, which we can say that, let me take you the size of pen. Now I will see. Yeah. So now chemical bond is as simple as that. The driving force, or we can say the force of attraction between the atoms. Let's suppose A and B is trying to form. So the force of attraction between here is simply nothing but what? A chemical bond. Now we there is a force of attraction that acts between the atom to make it as a stable one. Right. Now I will going to discuss you very most important for the examination point of view. Okay. Yeah. So let me tell you guys. Right. So if you see this particular graph, which is very most important for your examination. So when the two atoms are very far from each other, far from each other, let's suppose this is atom A and atom B. So the atom A is here and atom B is here. This is atom A and atom B. When we are trying to bring them, when we are trying to bring them near to each other, when we are trying to bring them near to each other, the distance between them will be decreases, and there is a force of attraction between them will develop. And there is a point where both A and B are trying to, the distance between them is X, and later where B and A came very nearly each other, then they will start sharing the valence electrons. Then they start sharing the valence electrons by forming a bond between them. So these particular plot indicates that the bond formation is taking place. Okay, so if you see the graph here, the graph is somewhere around looking like this. So this is the plot between D versus E. What is the D versus E? D is internuclear distance. What is the meaning of internuclear distance? So this is atom A and this is atom B. The distance between the two nucleus. So the distance between two nucleus is called as internuclear distance. So when we are trying to bring them together, earlier stage, the distance between them is more. Then as I am trying to bring them nearly together, when I am trying to bring them nearly, what happened? At certain time, the energy is very constant, constant, constant. When there is a bond formation is taking place, there is a decrease in energy takes place. Why the energy is been decreasing? Because bond formation is taking place. We know whenever there is a bond formation is taking place, there will be a stability will be attained. Okay, so this stability, because of the stability, there is a decrease in energy takes place. So at this particular moment, the atom will be very near to each other. The distance between them will be minimum, and this particular distance is called as bond length. Bond length is simply nothing but whenever two atoms are bringing near to each other, then there is a force of attraction, and then there is a stability will be developed by releasing energy, and we can say that very low in energy. We know that in chemistry, very, very most important, lower the energy, higher will be the stability. Lower the energy, what we are going to call it as higher the energy. Very, very most important. Okay. Higher the stability. Higher the stability. I'm so sorry. Lower the energy, higher the stability. So here the both atoms A and B trying to form a bond. So this is what the graph we can remember. So two atoms are very far from each other. When we are trying to bring them nearly together, just a minute, guys. Yes, now you can clearly say that whenever I'm trying to bring the both atoms very near to each other, that this energy will be remain same. When there is a bond formation is taking place, there will be a very less energy will be there. So these particular energy, usually for if I'm checking for H2 molecule, that is 435 kilojoule per mole. So whenever there is a bond formation is taking place, we know that forming of a bond will leads to the energy. Let's suppose if I'm seeing here, so this is initial stage. Okay, and whenever there is a bond formation is taking place, the distance between them D is called as bond length, and here some energy will be released. That is 435 kilojoule per mole. Okay, so this 435 energy will be releasing. This particular energy is called as bond energy. So to break the bond, let's suppose these are two hydrogen atoms. To break the hydrogen into individual ions, how much energy you need to give? You need to give 435 kilojoule per mole. एक mole के लिए, to break the 1 mole of H2 molecule, you need to give 435 joules of energy. How the graph will be plotted? The graph is very simple. When the two atoms are far from each other, the energy will be remain same. But whenever there is a bond formation is taking place, the energy will be decreases. So this is minus 435.3 kilojoule per mole. What this minus indicate? Release in energy takes place. Whenever there is a bond formation, energy will be released. And we know that bond strength, bond stability should be higher. If the bond stability should be higher, the energy will be lower. Lower the energy, more will be the stability. Energy will be the lower the energy, more will be the stability. I hope you guys understand. Next, in this particular chapter, we need to remember one thing, that is Okay, we need to remember one thing that is called as octet rule. Octet is very simple. You people already know that. What is octet rule? Octet rule is simply nothing but whenever two atoms are forming, their valence cell will get 8 electrons. Their valence cell will get 8 electrons. Exception 2 electrons for the H2 case. We can call it as a octet configuration, and we can call it as a duplet configuration. I hope you guys understand this one. So very simple is that, let's suppose if I'm talking about Cl2, what is going to happen? In Cl, we are having how many electrons? In chlorine, we are having 7 electrons. And another chlorine, how many electrons you are having? Again, 7 electrons. Okay. So now if you can see here, there is a bond formation between this chlorine and the bond formation between this chlorine. Now, if you count the number of electrons here, 1, 2, and 6. Total 8 electrons for this chlorine and total 8 electrons for this chlorine. So octet rule is simply nothing but to attain the noble gas configuration in their valence cell to make the compound or molecule stable. So there are so many violations are there for the octet rule. One is the transition metal. So transition metal, if you see, there is no octet configuration in the valence cell, but still they are existing. And next, they didn't discuss about pseudo-inert gas configuration. What is the meaning of pseudo-inert gas configuration? Pseudo-inert gas configuration means you will have 18 electrons in the valence shell. You will have 18 electrons in the valence shell. Let's suppose zinc, if you take zinc, you are going to get Ar 4s2 3d10. So now Ar is simply nothing but 3s2 3p6 4s2 3d10. Okay. Just a minute, guys. Yeah, I'm so sorry for the disturbance caused, guys. Yes. So now what I'm telling here, pseudo inert gas configuration means in the valence cell. Let's suppose I am telling you, just let me take one page here. So now you can see in this case, if I'm talking about zinc, zinc is having 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. This is the electronic configuration of zinc. But if you take Zn plus 2, if you take, then you will remove 2 electrons from fourth cell. Why? Because here n is equal to 4 is the valence cell. How do you find the valence cell? Valence cell can be determined with the highest principal quantum number. Highest principal quantum number is simply nothing but valence cell. So where you will remove the electrons? What is the meaning of plus 2? Plus 2 means removing of 2 electrons. Plus 2 means removing of 2 electrons. Where do you remove the 2 electrons? From the valence cell. How do you find the valence cell which is having highest principal quantum number? And here we can say highest principal quantum number is 4. So that's why the new configuration, I will write this as neon. Okay, then this will be 3s2, 3p6, 3d10. Now if you see n is equal to 3, so this is the highest principal quantum number, and now this will become the valence cell. For which one? Zn plus 2, this will become the valence cell. Now, if you count the electrons here, you are having 2 plus 6 plus 10. Total how many electrons? 18 electrons. So these 18 electrons on the valence cell is called as pseudo inert gas configuration. Pseudo inert gas configuration. I hope you guys are clear with this. If you are clear with the pseudo inert gas configuration, let me know through the chat box. Are you clear with this? Please let me know through the chat box. Guys, are you clear with this? Please let me know through the chat box. Okay, so octet is failed to explain this one. Octet rule is failed to explain this one. Okay, thank you guys. So octet rule is failed to explain the pseudo inert gas configuration. And next, what is the other drawback of octet? What is the next other drawback of octet is? The other drawbacks is simply nothing but didn't talk about the odd electron species. It didn't talk about the odd electron species. What is those? Let's suppose NO2 if I'm taking. NO2 if I'm taking, nitrogen is having how many electrons? Total 5 electrons. So now if I am telling here, so double bond O and double bond O, one electron is left over here. So this is odd electron species. So he didn't talk about the odd electron species. Okay. And second, what is the next drawback? He didn't talk about the electron deficient species. Electron deficient species. What are electron deficient species? Can you guys tell me? Like BF3. BF3, the boron is not having 8 electrons in the valence shell. Boron, if you take 1, 2, 3. Fluorine, if you take, okay, if you take the fluorine, the boron is having how many electrons, Appa? The boron is having only 6 electrons. It is 2 electrons less. So whenever there is a electron less, usually 8 electrons, then only it will be stable. But how many electrons are having? 6 electrons. 2 electrons are less. So the less electrons for the octet are called as electron deficient species. Okay, they are electron deficient species and usually called as Lewis acids. Usually called as Lewis acids. Why? What is the meaning of Lewis acids? They are ready to accept the electrons. They are ready to accept the electrons. They are ready to accept the electrons. Okay. So they are very ready to accept the electrons. So Lewis acids are simply nothing but electron deficient species, usually ready to accept the electrons. And next, if I am saying about last one, very, very most important. Next, if I'm talking about expanded octet, what is next one? Expanded octet. What is expanded octet, guys? Let's suppose if I'm talking about PCl5, phosphorus is right. Now, if you take PCl5, phosphorus is having 5 valence electrons, and chlorine, if you give the chlorine, how many chlorines it will be surrounded by? It will be surrounded by, yeah, 5 chlorines. Now, if you see here, if I'm trying to make the round, if you see here, so the total valence electrons are how many? Now you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Usually 8 electrons is called as octet. But now how many electrons are there? 10 electrons are there. So 2 electrons are extra. So that's why octet has been expanded. Octet has been expanded. So that is why this expanded octet rule is also limitation. Why these 10 electrons are there? This is due to p pi d pi bonding. This is due to p pi d pi bonding. We'll let you know in the upcoming class. Okay, p pi d pi bonding की वजह से ऐसा हो रहा है. So these are the limitations for octet rule. Okay, now next. Okay, so coordinate covalent bond. Next, if I'm talking about coordinate covalent bond. So now, what is coordinate covalent bond? Coordinate covalent bond is simply nothing but here nitrogen is having one lone pair electron. Okay, but the boron is having one vacant orbital. Now this nitrogen will give the lone pair to the boron. So these type of not at all completely giving the shared pair of electrons. These are just simply okay, donating the lone pair of electrons here. So this is called as what? Coordination covalent bond. So one atom accept the electron pair. So this is accepting the electron pair. So that is why this is called as acceptor. And this is a donating. That's why this is called as donor. I hope you guys are understand this one. And remember, these are called as coordination compounds. So all the coordination compounds are formed because of coordinate bond. Coordinate is very simple, where there is an atom which is ready to donate the electron where there is a empty. Okay, so if you see here, ammonia is there, and here you can see the boron trifluoride is there, and nitrogen is ready to share its lone pair of electrons. So the bond forming between these two molecules is called as what bond? Coordination covalent bond, or we can also call it as dative bond. So very simple. So dative bond and covalent bond is simply nothing but where the molecule is ready to donate. Okay, now next simultaneously, like let's suppose, yeah, So now simultaneously, if you see here, ammonia is there, lone pair, and we are having, well, let's suppose we are having H plus is there. H plus is simply nothing but proton. Proton, it is not having any electron. No electron is there. Electron was not there. It is only simply proton, because we know 1s1 is the hybridization, sorry, electronic configuration for hydrogen. Now one electron has been removed, so that's why it is having H plus configuration. So that is why it is what? Simply a proton. So proton means one vacant orbital is there, and now ammonia is there here. Now ammonia is there. This lone pair of electrons, this will be donated to this. So that's why you are going to get NH4 plus. So now hydrogen is ready to accept the lone pair of electron from nitrogen. So this is ready to donate. So the bond formed between ammonia, the bond formed between ammonia and H plus is simply coordination covalent bond, or we can also call it as dative bond. I hope you are clear with the basics. Okay, right. So next, very most important is VBT theory. Okay, so next one, if I am going to talk about this one. Yeah, so next one is VBT theory. So VBT theory is simply nothing but, yeah. So now if I am talking about a VBT theory, so VBT theory is depending upon the valence shell electrons anamata. Okay, so VBT theory, if I'm talking about, it is help us to explain the overlapping of orbitals and hybridization theory. So let me tell you what is VBT exactly. Let me tell you what is VBT exactly. Now we know that so VBT theory we are talking about. What is VBT theory? VBT theory help us to know the directional properties of the covalent bond. Directional properties of the covalent bond. It is help us to find the hybridization. Hybridization ka matlab led to the foundation for the hybridization. So valence bond theory means what? The involvement of valence electrons. So let's suppose if I'm taking two atoms. So this is atom 1 and the electron of it, and next one is, this is atom 2. Okay, so the electron of this. Now there are two important factors we need to keep here. One is attractive forces. And second one is what? Repulsive forces. Second one is what? Repulsive forces. So what are attractive forces are there here? Now, with respect to this electron and this electron, there is a strong repulsions are there. And with respect to this nucleus and this nucleus, strong repulsions are there. But simultaneously, one thing we need to observe, there is an attraction between this nucleus and the electron of that particular, and simultaneously attraction with respect to the other atom. So we can say that force of attraction, okay, between the nucleus of A plus electron of A, simultaneously force of attraction between nucleus of A with electron of B. So another force of attraction is what? Nucleus of B with electron of B, there is force of attraction, and simultaneously nucleus of B with electron A. Okay, so these are the dominating force of attraction. Force of attraction will be there between these atoms. And next one, very most important thing is repulsive forces. Next one is what? Repulsive forces. How do you find the repulsive forces? Repulsive forces between the nucleus of A and nucleus of B. These are the repulsive forces. And second one is what? Electron B plus electron A. So these two are having what type of forces? Repulsive forces. What type of forces? Repulsive forces. I hope you guys understand this one. Okay, thank you, Amaravati. I hope you guys understand this one. What type of forces are there? Repulsive forces and attractive forces. But according to the VBT theory, what exactly we are suggesting that there is dominance of attractive forces. There is a dominance of attractive forces. Okay, so that is why, because of the domination of attractive forces, there is a bond formation is taking place. Then is a bond formation is taking place. So this is explained by which theory? BBT theory. I hope you understand. So the dominance of attractive forces are there over repulsive forces. So bond formation is taking place, explained by BBT. Now, what is orbital overlapping concept? Orbital overlapping concept. What is the meaning of orbital overlapping concept? This is whenever you are having one particular orbital, where if you are having one unpaired electron, if you are having one unpaired electron and another atom with another unpaired electron, okay, and the spin must be opposite. The spin of electron must be opposite. Spin of electron must be opposite. So now this is atom A and atom B. When they are trying to form a bond, they will form a bond like this. Then they are trying to form a bond, they will form a bond like this. Okay. So these particular bond formation lead to a overlapping. So this overlapping is called as overlapping area. Overlapping area. So this is one atom of one electron, another atom of another electron in the valence shell, and definitely their must and should be unpaired. What are the requirements for the overlapping? What are the requirements for the overlapping? Number one, valence electrons should be unpaired, and second thing is electrons must be in opposite spin. Okay, when they are in opposite spin and the valence shell is consist of unpaired electrons, then it is ready for the overlapping. Now we are going to discuss about types of overlapping. Now we are discussing about types of overlapping. What are the types of overlapping? Yes overlapping. So S and S overlapping. Next SP overlapping. S and P overlapping. And next PP overlapping. PP overlapping. So these overlapping, okay, these three overlappings are called as sigma bond overlapping. What type of bonds are there? Sigma bond overlapping. Very most important. These are the three sigma bond overlapping. Now, if anybody asks sigma bond between PP and sigma bond between SP and sigma bond between SS, which is a stronger bond? Yes, sir. These are the three different type of bond formation. Among these, which is the stronger bond? If anyone asks, the overlapping of PP is greater than the overlapping of SS. Very most important. The overlapping of PP is greater than overlapping of SP and SS. Why? Due to area of overlapping. Due to area of overlapping is higher in case of PP. So PP ka overlapping area will be higher. So that is why the bond strength, or we can say the strength of the sigma bond for PP is higher. I hope you guys are clear. Now I am going to write here bond strength is directly proportional to overlapping area. Okay, the overlapping area. So the bond strength is directly proportional to overlapping area. And next, what is the other type? Now we are discussing about pi bond. Next, we are talking about pi bond. So now for the pi bond, if you see for the pi bond, so now let's suppose this is a internuclear axis. What is this? Internuclear axis. What is the meaning of internuclear axis? Where the nucleus are aligned in this particular axis. Let's suppose if I'm talking about p orbital. So let's suppose if you are considering it as a z axis. Okay, and this is y. So there is py orbital. We know that py orbital, and this is the nucleus. And another one is simply nothing but, okay, this is also nucleus. What is this? This is nucleus. So the nucleus is aligned in the z axis. So the overlapping between py, the overlapping between py, okay, or px is simply nothing but will give what? If z is internuclear axis, if z is internuclear axis, This overlapping is lead to which bond? Pi bond. So this indicate what? Pi bond, the overlapping. Okay. And this is also called as lateral overlapping. Lateral overlapping. And sigma bond is formed by head-on overlapping. Head-on overlapping, or we can also call it as axial overlapping. But pi bond is formed by lateral overlapping or sideways overlapping. Sideways overlapping. I hope you all guys are clear with this. Okay. Now, so next one, pi bond can be formed not only with this, they can also formed with a d orbital. Let's suppose if again this is z axis, internuclear axis. So let me draw. This is px, and if I am drawing for this. So this is d orbital. Let's suppose we can say dxy orbital, or we can say that. So this is the bond formation between them. This is d orbital and this is p orbital. So now p pi d pi bonding. What is type of bonding? It is p pi d pi bonding. Okay, and this one is what? P pi bonding. Usually observed for 2p pi, 2p pi you are going to observe. And this is 3p pi and 3d pi. So इसके बीच में आप लोग observe कर सकते हैं. So this is usually observed in phosphorus, silicon, sulfur, chlorine. So ठीक है ना? For these kind of elements, we will observe the p pi d pi bonding. Okay. So this is one type of overlapping, that is lateral overlapping or sidewise overlapping. Now another most important thing is, so now another most important thing is how to determine sigma bond and pi bond. How to determine the sigma bond and pi bond. Always remember, the single bonds are all the sigma bonds. Single bonds are always sigma bonds. Best example, if I am going to say CH4. CH4 carbon, H, 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 and H. So all these all are sigma bonds. Okay. Now, if you are seeing any double bond or triple bond or 4 bonds is also possible. 4 bonds is also possible. Then you will see pi bond, sigma bond, and delta bond. Okay, I'll show you. Just a minute, I'll show you. Let's suppose if I'm talking about O2. O2, how the bond formation will be there? Oxygen and oxygen. There is a double bond will be there. So always remember the first bond. First bond is always formed by which bond? The first bond will be formed by sigma bond. So the first bond is always formed by sigma bond. So if this is sigma and the top one is pi bond. Next one is N2. N2 is, how do you write the N2? N triple bond N. So the down one is sigma and this is pi and this is a pi. So this is how you need to remember the number of sigma pi bonds. Very clear. I hope everyone is clear with the number of sigma bonds and pi bonds. Now let's have a practice here. Now let's have a practice. Find number of sigma and pi bonds. Find the number of sigma and pi bonds. Let's suppose if I'm writing here CH2 double bond, CH bond, CH double bond, CH2. Always remember, hydrogen is always formed what type of bond? Sigma bond. Hydrogen is always formed what type of bond? Sigma bond. Now if you can see here, this carbon is having 2 hydrogens and double bond carbon, hydrogen, carbon, hydrogen, double bond, C, one hydrogen is here, another one is hydrogen is here. Now find the sigma bonds. I told you all the single bonds are the sigma bonds. So these all are the sigma bonds. And we know the first bond is always sigma bond. The first bond is always sigma bond. And you are having 2 pi bonds. So this is pi bond 1 and this is another pi bond. So you can see 2 pi bonds and 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sigma bonds. 9 sigma bonds. Okay. Very good. Super Rajkot team. Very good. You people are really amazing. Okay. Now try to find. Now try to find for the number of sigma bonds for this compound. Now try to find for the calcium carbide. Try to find for the number of sigma and pi bonds. Can you find the sigma and pi bonds for the calcium carbide? Okay, can you find it for calcium carbide? Yes. Now calcium carbide is formed by this compound. So calcium carbide will be formed by this compound because this is asked in JEE Main 2020 90 में इसके ऊपर पूछा था. So this is sigma bonds are there. So remember, always metallic carbides you will form like this kind of structure. Okay, very most important. This you people need to remember for sure. Okay, now another question. Find the ratio of sigma and pi bond in benzene. Very most important. This is also asked in JEE 2020. JEE 2020. Come on, guys. Find the number of sigma and pi bonds in benzene. Can anyone tell me? How do you find the sigma bonds and pi bonds in benzene? Very simple, right? We just draw the, just a minute, I'll erase this one. You take the another color. This is very easy, no? I used to write in the slides. Now, alternate double bonds you keep and just keep each carbon, you just keep one hydrogen. Each carbon, you just keep one hydrogen. Okay. In each carbon, you just keep one hydrogen. Now, if you see in this case, okay, now if you see in this case, now total number of sigma bonds we need to count. 1, 2, 3, 4, 5, 6 sigma bonds. And again inside the carbon and carbon, 1, 2, 3, 4, 5, 6. So total 12 sigma bonds plus 3 pi bonds. So the ratio is 12:3, or we can also say that 4:1. So this is sigma is to pi bond ratio. I hope you all guys understand this one. I hope you all guys understand this one. Please let me know through the chat box. Yes. So now next one is how to find the hybridization. How to find the hybridization. Okay. How do you find the hybridization, guys? Very good. How do you find the hybridization? There is a formula for the finding of hybridization. Very most important. Hybridization number can be calculated by half into valence electrons of an atom plus number of single bonds plus negative charge over the molecule minus positive charge of the molecule. Okay, so let's suppose if I am talking about if you want to find the hybridization of ICl2 minus, let's suppose ICl2 minus is the hybridization you want to find. Now first point, how to find the central atom? Many times students often get confused to find the central atom. Very most important, some of the rules to find the central atom, that is it should be less electronegative, and the size should be more over the other elements. It should be less electronegative, the size should be more, and third thing, electronegativity difference should be more. So we can also say that it should be less electronegative, its size should be greater, and what else we can also say from there? Okay, size should be less and it should be a less electronegative. These two factors are enough. Now iodine is more big in size and less in electronegative, so iodine will be the central element. Now what are the valence electrons of iodine? 1, 2, 3, 4, 5, 6, 7. So valence electrons for iodine is 7 electrons. I'll change the color now. Next, how many single bonded are there? Always remember, halogens, okay, and hydrogen always form what? Single bonds. So how many single bonds are there? 2 chlorines are there, so 2. So how many charges are there? 1 charge. Which charge? Negative charge. So 1 negative charge is there. Now writing the hybridization number. How we are going to write here? Half into valence is how much? 7 plus How many single bonds? 2. And what is the charge? -1. -1 means we need to add +1. So then this will become 8 by 2, 4. So now ICl2 minus is becoming sp3 hybridization. sp3 hybridization. So another last point, just remember, if the hybridization number is 2, then the hybridization is sp and the geometry is linear and the bond angle is 180. And if the hybridization number is 3, then it will be sp2. Best example, if I can take bf3. Best example, if I can take, that is bf3. So bf3 is simply nothing but half into 3 plus 3, that is 6 by 2, 3. So hybridization number 3, sp2, and this is trigonal planar, and the bond angle is 120 degrees. How the bond angle? Fluorine, the bond angle is 120 degrees. Next one is 4, that is sp3. We can also call it as tetrahedral. Best example is CH4. CH4 is the best example. The bond angle is 109 degrees, 28 minutes. If the hybridization number is 5, that is sp3d, then this is called as trigonal bipyramidal. So what is the bond angle here? 90 and 120. How, sir? Just see, sir. So I will draw here. Yeah, so just to see here, what is going to happen? Here, phosphorus is there here, and all the chlorine atoms at the corner, chlorine, and chlorine. So the bond angle is 120 here, the bond angle is 120, the bond angle is 120. And another chlorine on the top, another chlorine at the bottom. So this is 90 degrees, and this one is 90 degrees. So 3 120 degrees are there, and 2 90 degrees are there. And number 6 is for what? sp3d2, which is also called as octahedral. All the bond angles are 90 degrees. Best example is SF6. If you draw the SF6 will have a plane here and 4 fluorines at the plane and 1 fluorine at the top, another fluorine at the bottom. The bond angle is 90 degrees. And 7, that is sp3d3, which is also called as pentagonal bipyramidal. Okay, so what is the bond angles are here? Bond angle is 72 degrees and the 90 degrees. Okay, I hope you all guys understand this one. Okay, I hope you all guys understand this one. Best example for this one is IF7. Best example for this one is IF7. Okay guys, that's it about today's class. Just I am launching the NPS poll. So please give me the reasons so that I can end the class today. Do you guys understand this one? How is the class today? Please mention in the chat box. How is the class today? Please mention in the chat box. I know a bit faster I am going, but we are in the crash course. So just we need to revise certain things. Don't worry. Tomorrow onwards, we will go very slowly because GOC we are starting from Saturday. So GOC we are starting. No need to worry about anything. We will go with the basics. Okay. We'll go with the basics. From tomorrow onwards, GOC is started. Okay. Okay, guys. Thank you so much for your time. We'll see you in tomorrow class. Bye-bye.